So we're going to focus on binary trees. Okay, let's define it. Here's my class definition. Now I could have called this a node since the elements are nodes, but because trees are always composed out of nodes, I'm just going to call the class a binary tree. It's going to inherit from the underlying basic object class as we saw before. And what do I know about a node in a tree? Well, it needs a value, and it might have a left branch to a child, and it might have a right branch to a child. There's only going to be two branches since it's a binary tree. And it might have a parent. So when I create an instance of a node or a tree, I'm going to pass in one argument, which is its value. It's got to be there. And that's going to get stored away, just using the standard way we would do it. I'm going to bind that in that instance. But because I will need, eventually, or I might need, a left branch, a right branch, and a parent, I'm going to create bindings for those which are initially set to none. Okay, that'll create my node. Now, I got to link it up. I got to create the branches. And here I'm going to make a simple decision, which is I'm going to have three methods associated with an instance. Let me set the left branch, the right branch, or the parent. And for example, if I pass in a node to this instance, to the method for this instance called setLeftBranch, it simply creates a binding, resetting that binding for left branch to be that node. And that creates my tree. Of course, if I can create it, I need to get it back out. If I want to explore the tree, I have to be able to follow branches. So I will have a set of methods that provide for me access either to the value of the node, the left branch of the node, the right branch of the node, or the parent of the node. And it's doing exactly what we've seen before, of retrieving that information from the instance and passing it back out. And then finally, I'd like to have an easy way of looking at a tree by being able to print out the values associated with nodes. And so I'm going to define my str or string method just to use the value of a node as the way in which I print out information. Okay, let's build a tree. Here's a simple version of a binary tree. On this side, I've created a set of nodes. You can see I'm just calling the class at each point. And just for convenience, I'm using n for node and then the value 5 to represent the node 5. So I've built a set of nodes, and then I need to connect them together. And notice what I'm doing here. On this side, I've got a pairing of creating a branch and a parent. I could have buried that, by the way, inside of my class definition, that when I actually create a branch, a left branch or a right branch, I could automatically also set the parent connection at the same time. I chose to separate those out, so I'm relying on the user to put the parent information in. Probably better to do it the other way, but this is straightforward. So there I've just got a listing where I'm connecting things up together, and if I look at that, it creates this tree. Notice, no more than 2 branches for any node, but in some cases only 1 branch, like here or here. There's my root, there's the rest of my tree structure, and in the next segment, we're going to use this as an example as we write code to search through trees.